We proceed the chapter similar triangle, and in the last video we have discussed the BPT theorem, basic proportionality theorem, theorem number 1. Now we discuss theorem number 2. This is the converse of BPT. Converse of BPT. Its statement is if a line divides any two sides of a triangle in the same ratio, if a line divides any two sides of a triangle if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. Then the line must be parallel to the third side. In the previous theorem in BPT, it was given that the line is parallel to third side. Here we have to prove that line must be parallel to the third side. And in BPT, we proved that sides are in proportional. Here already we have given that the sides are in proportion. So this is the converse of BPT. So firstly we write the given condition. So given triangle ABC, in which there is a line DE. Line DE divides sides AB and AC in the same ratio. So given triangle ABC, in which AD upon DB equals to AE upon EC. Means we have given that the sides are in proportional. Sides are in proportion. AD upon DB equals to AE upon EC. And we have to prove that the third side, we have to prove that the side DE is parallel to the third side. DE is parallel to BC. To prove DE is parallel to BC. To prove that side DE is parallel to BC. So there is a construction. We prove this theorem by contradiction. We prove this theorem by contradiction, and we suppose that DE is not parallel to BC. We suppose that DE is not parallel to BC. So we prove this theorem by contradiction. So let us suppose that DE is not parallel to BC. Let us suppose that DE is not parallel to BC. Then draw a line DF. Then draw a line DF such that DF is parallel to BC. We suppose this, we prove this theorem by contradiction. Since we have to prove that DE is parallel to BC, so we contradict. We suppose that DE is not parallel to BC, and we did a construction that if DE is not parallel to BC, then we suppose that DF is parallel to BC. So this is the contradiction. Suppose that DE is not parallel to BC, and if DE is not parallel to BC, then we suppose that there is another line DF is parallel to BC. So if DF is parallel to BC, as we suppose, as DF is parallel to BC, it means AD upon DB must be equal to AF upon FC. If DF is parallel to BC, it means sides must be in proportion. So AD upon DB, AD upon DB equals to AF upon FC. Name it first number equation. AD upon DB equals to AF upon FC. By construction, we suppose that DF is parallel to BC, then the sides must be in proportion, means AD upon DB equals to AF upon FC. But we have given that AD upon DB equals to AE upon EC. But AD upon DB equals to AE upon EC. This we have given. Second number equation. So from first and second, since LHS is equal, so we can equate RHS, and we conclude that AF upon FC is equals to AE upon EC. From first and second, we conclude that AF upon FC equals to AE upon EC. So AF upon FC equals to AE upon EC. Now add 1 both sides. Add 1 both sides. So it becomes AF upon FC. AF upon FC plus 1 equals to AE upon EC plus 1. We can add same quantity both sides. So by adding 1, we get AF upon FC plus 1 equals to AE upon EC plus 1. And by taking LCM, FC we get LCM, so AF plus FC equals to AE plus EC upon EC. And AF plus FC can be written as AC. So AC upon FC. And AE plus EC can also be written as AC. So AC upon EC. So AC upon FC equals to AC upon EC. AC gets cancelled and we get the result FC equals to EC. We get the result that FC equals to EC. FC equals to EC, but this is not possible. FC is equals to EC is not possible because E and F are two different points. FC equals to EC is not possible because F and E are two different points, and this is only possible when F coincides on E. This is only possible when F coincides with E. When F and E comes together, when F coincides with E, then this case is possible. So this is the contradiction. So we write that FC equals to EC, which is not possible. Which is not possible because F and E are two distinct points. Because F and E are two distinct points. This is only possible when E and F coincide. This is only possible when E and F coincide. It means our supposition is wrong. It means our supposition is wrong. It means our supposition, which we have supposed, our supposition is wrong. And what we have supposed? We have supposed that DE is not parallel to BC. If it is wrong, then what is right? The right is DE is parallel to BC. It means our supposition is wrong. Hence, DE is parallel to BC. So this is the converse of basic proportionality theorem, BPT. We have given the triangle ABC and also given the sides are in proportion, means AD upon DB equals to AE upon EC, and we have to prove that DE is parallel to BC. So we suppose that DE is not parallel to BC, and we made a construction that DF is parallel to BC. If DF is parallel to BC, then AD upon DB is equals to AF upon FC. This was the first equation, and we have given that AD upon DB equals to AE upon EC. which is second number equation. So from first and second, LHS is equal. So we create the RHS and we get AF upon FC equals to AE upon EC. And add 1 both sides. So AF upon FC plus 1 equals to AE upon EC plus 1, and by taking LCM we get AC upon FC equals to AC upon EC. AC gets cancelled and it comes FC equals to EC. So F of FC equals to EC, this is not possible, and this is only possible when E and F coincide. And when E and F coincide, it means DF lie on DE. Thus our supposition is wrong. Hence DE is parallel to BC. Now we do exercise 6.2. Exercise 6.2. The first question of exercise 6.2 is, we are given a figure that is triangle ABC. There is a triangle ABC in which side DE is parallel to BC. Side DE is parallel to BC. So we have given that DE is parallel to BC. In triangle ABC, DE is parallel to BC and AD is 1.5 centimeter. AD is 1.5 centimeter. Length of DB is 3 centimeter. Length of AE is 1 centimeter, and we have to calculate EC. Find EC. So we use the basic proportionality theorem BPT because in triangle ABC DE is parallel to BC. So we use the concept of BPT theorem. So in triangle ABC, if the side D is parallel to BC, then the sides must be proportional. So AD upon DB equals to AE upon EC. And let the length of EC is X. So AD is 1.5, DB is 3, AE is 1, and EC we have supposed X. Then remove the decimal. So we get 1 by 2, and by cross multiplication X equals to 2. So we get the value of X, which is side EC. So EC equals to 2 centimeter. EC equals to 2 centimeter. The next question. The second part of question 1. We have given triangle ABC in which DE is parallel to BC. ABC DE is parallel to BC, in which we have to calculate AD. DB is given 7.2 centimeter. AD we have to calculate. DB is 7.2 centimeter. And AE is 1.8 centimeter. EC is 5.4 centimeter. And we have to calculate AD. Find AD. Side DE is parallel to BC in triangle ABC. So again we use BPT theorem. From BPT, since DE is parallel to BC, so we can use BPT theorem. So AD upon DB equals to AE upon EC, and the length AD we have to calculate. The value of DB is 7.2, AE is 1.8, and EC is 5.4. Decimal be removed. From here decimal also removed and multiplied in numerator by 10. So 10x into 54 equals to 18 into 72, and the value of x 18 into 72 upon 10 into 54. 24 3 is 72, and 24 by 10 means 2.4. So the value of AD comes to 2.4. AD equals to 2.4 centimeter. Next question, question number 2. E and F are points on the sides PQ, PR of triangle PQR. Given triangle PQR. Given triangle PQR, in which E and F are points on the sides PQ and PR. There is a triangle PQR. PQR. E and F are points on side PQ and PR. For each of the following, state whether EF is parallel to QR. We have to show that whether EF is parallel to PR, QR. Show whether EF is parallel to QR. And the first case is given. PE equals to 3.9 centimeter. Side PE equals to 3.9 centimeter. EQ equals to 3 centimeter. EQ equals to 3 centimeter. Then PF equals to 3.6 centimeter. PF equals to 3.6 centimeter. And FR equals to 2.4 centimeter. FR equals to 2.4 centimeter. And we have to check whether EF is parallel to QR. So EF will be parallel to QR if the sides are in proportion. Means we find the ratio PE upon EQ. So the value of PE is 3.9 and the value of EQ is 3. So 3.9 divided by 3. This is 1.3. 1.3. Now we calculate the ratio of PF upon FR. So PF upon FR. The value of PF is 3.6 and the value of FR is 2.4, decimal removed, and it goes by 12 into 3 and 8 into 3, then 4 into 3, 12, 4 into 2, 8. So this comes 3 by 2. And this is 1.3, means 13 by 10. So sides are not proportional. Sides are not in proportion. Since PE upon EQ is not equals to PF upon FR. PE upon EQ is not equals to PF upon FR. Therefore, we conclude that EF is not parallel to QR. EF is not parallel to QR in the first case. In the first case, we draw the conclusion that EF is not parallel to QR. Now for second case, in second case, PE is 4 centimeter. PE is 4 centimeter. QE is 4.5. PF is 8. PF is 8 centimeter and FR is 9 centimeter. So we find the ratio PE, it is RF. RF is 9 centimeter. So PE upon QE. PE upon QE. The value of P is 4, QE is 4.5. Remove the decimal. So it gives 40 by 45. 8 by 9. The ratio 8 by 9. Then we find the ratio PF by RF. So PF by RF. PF is 8, RF is 9. PF is 8 centimeter and RF is 9 centimeters. We conclude that PE upon QE is equals to PF upon RF. Therefore, since sides are in proportion, therefore EF is parallel to QR. So in case second, EF is parallel to QR.